Okay, so let's deal with some more chain rule, which is dealing with functions. So f of g of x is what capital F is given as. Find capital F prime of 2. So you have to have this memorized, that this is how you take the derivative of a nested function with f of g of x. Now I'm going to put x equal 2 in for everywhere there's an x. Then I'm going to use that g of 2 is 3. So then that gives me 3 right here, so f prime of 3. And then I'm going to use the fact that g prime of 2 is given to me as -4. So I replace that with -4. So now I can go use the fact that f prime of 3 is given as 4. So I get 4 times -4, and that gives me a -16. All right, so moving on to this next one. So here's the function. Find the 47th derivative. So it could say that in words, or you could be asked to find this, or you could ask to find this. All these three things are the same way of saying take the 47th derivative. All right, so again, and one important step is to write the original function down again, take the derivative of sine, you get cosine, carry the 3x along, and then multiply by the derivative of that 3x. That's what that 3 is. That's chain rule. So I'm going to encourage you to rewrite it and put that 3 out in the front. Then take the derivative again. So the derivative of the cosine is negative sine. I carry this 3 along, and then carry this angle along to take the derivative of cosine is negative sine, and then multiply by the derivative of the angle again. So another 3. So I get 2 3's, so -3 squared sine of 3x. So this is, I'm establishing a pattern, so do not multiply the numbers together, so that you can see how the numbers are growing. So carrying along this -3 squared, take the derivative of sine, you get cosine, carry the angle along, and then take the derivative of the angle. And so that gives me 3 factors of 3 because I'm using chain rule again and again. One more time, the fourth one should give you the same basic trig function. So if I take the derivative of cosine, I get negative sine. So that negative will go away. So I carry along the 3 cubed sine, carry along the angle of 3x, then multiply by the derivative of that 3x. So I have 4 factors of 3 times sine of 3x. All right, this does get us back to the original base trig function. We do have some numbers growing out front, but we're expecting that with chain rule. Right, now I want to figure out how many multiples of 4 fit into 47. So I know 4 times 11 is 44, so this would be 44 derivatives. This would be 45. This would be 46. So this would be the 47th derivative. So the base trig function would be negative cosine of 3x, and then I have to add in this factor of 3 to the 47th power. Okay, so I've got quite a few expressions here. So to take the derivative of this f of 3 to the x, you take the derivative of the f first, so that's f prime. You carry that along, and then it's your job to take the derivative of 3 to the x, and that's 3 to the x times ln of 3. All right, so the g is a f of x all cubed. So this is good old chain rule again. You bring the 3 down, you carry the inside along, you subtract 1 from the exponent, and then you multiply by the derivative of the inside function. So capital H is e to the g of x. To take the derivative of e to the stuff is e to the stuff times the derivative of stuff. And then this one here, g is the most outside function, so I take the derivative of g, I carry the e to the x along, then I multiply by the derivative of the e to the x, which is just e to the x. All right, so this function right here, to take the derivative of it, has everything going on. So quotient rule is the most outside operation. Then in the numerator, I see product rule. And in the denominator, I see chain rule. All right, so let's go at it. So it's low, d high. So taking the derivative of the high, I see product rule. First d second plus second d first. Subtract high, And then d low, derivative of the low, is the chain rule. Take the derivative of f, carry the g along, multiply by the derivative of g. Square the bottom, and off you go. All right, so we're asked to find capital F of prime of 2. So everywhere there's an x, you're going to put in a 2. So if there's this little x here, you're going to put in a value of 2. So take the time to put the 2's everywhere, right? Especially this one right here. That's a 2. That's this right here. Then take the time to slowly go through. So g of 2 gives me 3, right? And then f prime of 2 gives me 5. This g of 2 here gives me another 3. So go slowly through. So you pick out like f of 2 gives you negative 2, and then g prime of 2, that gives you a negative 1. So then go find f of 3, which is 2, and f prime of 3, which is 4. And then go figure it out what we have on the top, and we end up getting 16 minus 16, which is 0. All right, so this has lots of constants in it, so I shouldn't need to tell you. I could have just given this to you, but a, b, and little k are all constants. T is the variable. So let's just remind ourselves about constants. If I take the derivative with respect to t of a by itself, that's 0. If it's at, then it's just a number times t. That just gives you a. If it's at squared, you're carrying the a along. You're taking the derivative of t squared, which is 2t. So if I have derivative of e to the at, that's like saying derivative of e to the stuff is e to the stuff times the derivative. And then e to the negative at, same idea. Derivative of negative at is negative a. All right, so this one will take the derivative of p is going to be quotient rule. So this is low. D high is just the letter a minus high, and then this is d low. Derivative of b is 0, and then the derivative of e to the stuff is e to the stuff times the derivative of stuff. Square the bottom, and off you go. So now I'm going to put t equals 0 everywhere. So t equals 0 gives me e to the 0. This t is 0. Oh, so that's going to make this whole term go away, and then I have e to the 0 down here as well. So I get b plus 1 times a over b plus 1 squared. So that simplifies to this.